Today we're looking at the volumes of prisms and cylinders. And so the first thing that we need is the formulas for those. So the volume of a prism and the volume of a cylinder. And note again, there's a reason that these two things get put together. It's because mathematically, as we're finding volumes or areas of them, they actually are basically the same figure. So mathematically, as we do them, they're the same. So the volume of a prism is the area of the base times the height. So kind of think about it this way. If you took that base and you moved it over and over and over again to get that height until you had the actual prism itself, you would have that whole volume. You'd have to do it infinitesimally many times to do it, but it would work that way. Think about if it's easier, like a deck of cards, right? And it having, it's 52 card deck of cards, right? You have 52 layers. Now they actually have a thickness there, but you can kind of see how that might add up that way, right? And then the volume of a cylinder is also the base times the height, except the base of a cylinder is always pi r squared, the area of a circle. And then we have times the height. A quick note here, I'm not going to write out his name, but we will look at one problem that is supposed to be like this. This works whether or not the prism or cylinder is a right prism or cylinder. So even if the figure is slanted, so like if you took a deck of cards and you kind of just push them over just a little bit, right? The volume of that deck of cards would not change, right? Its shape would change a little bit, but the volume would stay the same. All right, so looking at a couple of examples here, we'll do 4 total. We have a triangular prism that we'll start with. Ooh, that should have been more like this. Ignore that a little bit. And this is why you should use pencil. All right. All right, we have our prism. And on this one, it's going to give us the height of the base, which is 1.5. So remember, when I say height here, it can mean 2 different things. It can mean the height of the base for the triangle, or I can mean the height of the prism itself. The height of the prism is 4. And the base here is 3 centimeters. So the volume is the base times the height. This is the base, the area of the base. The bases are triangles. That means the volume is 1/2 the base times the height. However, I don't really want to call it a height here because I'm going to have 2 h's. So I'm going to call it the altitude, right? So the base times the altitude times the height. So I have 1/2 the base of the triangle is 3. The altitude of the triangle, or the height of the triangle, is 1.5. And the height of the prism itself is 4. So I get, well, I can do this in any order. So 1/2 of 4 is 2, times 1.5 is 3, times 3 is 9. And so the area is 9 centimeters cubed. Look at another triangle. And it's going to have a height, actual height of 15. The hypotenuse of the base is 12. and it's going to have a 30-degree angle here. The base is a 30, 60, 90 triangle. All right, again, since this is 12, and we're saying it's a prism, this must also be 12. That's the hypotenuse. Therefore, the short side must be half of that, which is 6, across from the 30-degree angle. And then across from the 60-degree angle is 6 root 3. The volume here is the area of the base. The area of the base is a triangle, so it is 1/2. And since it's a right triangle, the legs are the height and the height and the base, right? So we have 1/2 the 6 times 6 root 3 times the height of the prism itself, which is 15. And I would just type all of that into the calculator. 0.5 times 6 times 6 root 3 times 15. And I get about 467. And I'm going to go to the nearest tenth here. Again, your book might go to the 100, so you'll just need to pay attention. 467.7, and we were in centimeters, so we're in centimeters cubed. All right, as usual, the volumes for prisms, the volumes for cylinders are easier. We have a little cylinder. Say it's 2 feet by 1 foot, not drawn to scale. Volume is pi r squared times the height. Radius is 2, and the height is 1, so this is 2 squared, which is 4, times the height of 1, so we just get 4 pi. That is about 12.6 feet cubed. And I have plenty of room, so I'm just going to go below here. And finally, I'm going to do the best I can with this. Though arguably, it's not going to be perfect. This is supposed to look slanted, so it's supposed to look like it's not standing straight up, right? In fact, maybe to help us, so this base is flat on the surface here. This base is parallel with it. And what is its height? Well, its height is 12 feet, right? And then it's going to have a 1.5 foot radius, right? So I don't remember if I mentioned the guy's name. I'm not going to write it down. Cavalieri's principle says that even if it's slanted, so even if it's not straight up, the volume of the prism or cylinder still works, right? So the volume of this is still pi r squared times the height. We have 1.5, the radius squared. The height here is 12, right? And the, you need to multiply by pi. Note, note that the length here is more than 12, right? It's the hypotenuse of this right triangle, so it's more than 12. It is not helpful in finding the volume. We don't care about what this length is. We care about what the height is. All right. just put it in a calculator, 1.5 squared times 12 times pi, and I get about 84.8 feet cubed. And that is all that we're doing today, is finding volumes of those two types of shapes.